Hello everyone. Today we are going to explore an essential dimension of artificial intelligence, that is AI models. So AI models are not just mathematical constructs, they represent the logic, patterns and intelligence behind how machines think, learn and design. So whether it's Google search, self-driving cars or voice assistants, there's always a model behind the scenes making it possible. So in this lecture, we'll go beyond just naming types. We will understand how AI models are built, what problems they address, and how they reflect the philosophies of AI thinking. And before we jump into modeling itself, let's quickly revisit where we are in the journey of understanding AI. So we have already discussed AI techniques like reasoning, learning, and perception. We have touched upon real-world scenarios where AI is used, and we have encountered foundational challenges such as problem definition, search algorithms, and control strategies. Now we are going deeper to understand how we model these problems so they become solvable by AI systems. So let's here begin with the big question, why is modeling important in AI? Imagine you want a robot to navigate a building. So how do you express the task in a way a machine can understand? So that translation from the real world to machine understandable representation is what is called modeling. So AI modeling involves defining the environment such as a maze or a game, identifying agents, goals, constraints, and rules, using mathematical, logical, or symbolic systems to represent reality. For example, a maze models, which models the concept of navigation, a logic theory mission which captures deductive reasoning. Chess becomes a controls setting to study intelligence under rules. Knowledge acquisition and representation, which form the basis of expert systems. So now let's start with the maze hypothesis. Think of a maze not just as a puzzle but as a metaphor. A maze represents uncertainty, choice, obstacles, and goal seeking behavior. So in a maze is used to model navigation problems, pathfinding, search strategies, agent environment interaction. So for instance, in robotics, solving a maze is akin to having a robot move from its base to target without bumping into walls. The AI model must evaluate all possible paths and choose the optimal one, often using algorithms like A star or breadth first search. It teaches us how agents perceive the world, evaluate choices, and make decisions under constraints. So this maze a human at any point of time analysis the maze for choices we could find those which can lead to the goal. So these choices and maze based approach can help in solving many multi alternative solution problems. So moving on to logic theory missions. These are only AI models that attempt to simulate human reasoning through formal logic. So think of a system that when given a set of premises like AI, humans are mortal, and Socrates is a human, this can conclude Socrates is mortal. Okay, so this was one of the first real attempts to automate reasoning, to model how humans draw conclusions using the logic. Such models are foundational to AI techniques like propositional and predicate logic, inference engines, automated theorem proving. So, although this logic is deterministic and crisp, it forms the basis to many modern reasoning systems and knowledge based agents. So, next is AI model. This is a general view. Here we take a step back and ask what is an AI model fundamentally. So, an AI model is a structured representation of a problem and the reasoning mechanism to solve it. It can include symbolic models, that is based on rules and logic, statistic models based on data and probability, semiotic models which is based on science and meaning, neural models is based on learning from patterns. So each model has its own philosophy. Some mimic rational thinking, others mimic the pattern recognition, and some focus on human like communication. Choosing the right model depends on the nature of the problem. So now let's consider chess as a classic environment for modeling AI. So why chess? Because the environment is fully observable and deterministic. So there are clear goals, that is checkmate the king, right? The number of possible moves is fast but computable. So this makes chess ideal for testing, planning, decision making, and search algorithms. So in fact, early AI systems like IBM's Deep Blue used this domain to showcase AI capabilities. Today, advanced systems like AlphaZero have taken it further by learning from scratch using the reinforcement learning and self-play. So chess remains a symbol of how well an AI system can model, reason, and optimize. Okay. And one of the most dynamic areas of AI modeling today is natural language processing. NLP models which aim to make sense of human language, which is messy, ambiguous, and content dependent. To model this, AI systems use syntax and semantic parsers, statistical language models, transformer models like BERT GPT, word embeddings, word embeddings, just like word to vec. So unlike logic-based models, NLP models which requires training on massive data sets and use probabilistic reasoning. So here, which is modeling means teaching the machines to understand meaning, detect the context, generate responses, and even summarize or translate content. So next is semiotic models. So now let's turn on philosophical semiotic models. That is, these models are based on science, meaning, and communication. They explore not just data or logic, but how meaning is constructed and interpreted. Semiotic models are inspired by linguistics and communication theory. They are useful in human-computer interaction, knowledge representation, social robotics. So imagine a robot interpreting a hand gesture as a signal to stop. It is not just about detecting the motion, it's about understanding meaning in context. Okay, so this kind of modeling asks, how do symbols represent the reality? And how can the machines interpret them like humans do? Okay. And finally, the statistical models, the backbone of the most modern AI. So these are built on historical data, probability theory, statistical inference. So they are used to recognize patterns, for example, in images, speech, and it makes predictions. So it is, for example, spam detection, perform classification, so it email the categories and aid in decision making under uncertainty. For example, a weather prediction AI uses decades of data to learn correlations between the conditions and outcomes. So these models are data driven, often trained using machine learning. So they are especially effective in environments where patterns are subtle and too complex for rule based logic. Okay. So finally, today we explored how different problems in AI which requires different models, from logic-based reasoning in early AI to modern data-driven learning. So each model reflects a unique philosophy of intelligence. Modeling is where real-world complexity is translated into computable structures. It's where engineering, mathematics, and cognitive science meets. Okay, so that is. Thank you.